Hey there, and welcome to this explainer. Today, we're going to build a fully compliant digital dashboard. Why? To track the incredibly strict resource math of the chemical sector. Think about it. This industry takes raw feedstocks and transforms them into over 70,000 diverse products. It's massive. But doing all that requires absolutely staggering amounts of energy and water. So let's break down exactly how you measure those inputs so you can avoid massive regulatory risks and potential plant shutdowns. Let's dive right in.
Here is our agenda for today. First, decoding the SASB dashboard. Then, energy management metrics, followed by the rules of renewables. After that, water management metrics, mapping water stress, and finally, why resource math matters.
Section 1. Decoding the SASB dashboard.
Okay, so the entire foundation of our compliance dashboard really relies on two specific SASB metrics. We're looking at RT-Chase 13A.1 for energy management and RT-Chase 40A.1 for water. And listen, these aren't just vague guidelines. They are exact blueprints. Because the chemical sector faces intense scrutiny over its fossil fuel reliance and immense water usage, this table provides the precise formula you need to track inputs transparently across the entire industry.
Section 2. Energy management metrics.
When we're tracking total energy consumed, that big aggregate number absolutely must be reported in gigajoules. This is going to include your purchased grid electricity, direct fuel usage, heating, cooling, steam, and any self-generated power. But watch out, because there's a really strict mathematical rule here. When you calculate energy from fuels, you have to use higher heating values. Basically, that means you're measuring the absolute maximum gross heat energy released during combustion, and you've got to use baseline data from the IPCC to do it.
Now, slicing up that massive total gigajoule number into grid electricity, self-generated energy, and renewables is absolutely vital. You know as well as I do that energy purchases take a huge bite out of production costs and chemicals. By breaking down that aggregate number, companies can spot immediate trade-offs in their operational costs. They can test the reliability of their supply chains and actually measure the regulatory risks tied directly to their specific energy mix.
Section 3. The rules of renewables.
Let's talk about claiming renewable energy, because there is a golden rule you have to follow. If you generate green power on site, or if you buy it through a power purchase agreement, you must retain and literally retire the renewable energy certificates or guarantees of origin on your own behalf. Think of it kind of like a receipt. If you sell that receipt to someone else, boom, you lose the claim entirely. To avoid any double counting, you cannot report that energy as renewable on your books if the certificate is gone.
Furthermore, you can't just take credit because the broader local grid happens to be getting greener. The standards are incredibly explicit on this point. Any renewable energy in the grid mix that falls outside of your direct control is strictly excluded from your percentage. So you can only claim what you explicitly control, what you generate yourself, or what you purchase through certified programs. Period.
Section 4. Water management metrics.
All right, moving over to the water data. Here, the mandated standard unit shifts entirely to thousands of cubic meters. And this covers water withdrawn from absolutely everywhere. We're talking surface water like rivers, groundwater, collected rainwater, and of course, your standard municipal supplies.
To really accurately expose operational water risk, SASB requires a sequential calculation. It's almost like a funnel. First, you measure your total water withdrawn. Second, you calculate the total water consumed. And finally, you isolate the percentage of those figures that actually exist in highly stressed regions. It's a very deliberate, step-by-step process that systematically narrows down your operational vulnerabilities.
Now, there is a very strict definition of what it actually means to consume water. You see, withdrawn just means taking it from a source. But consumed, that means water that evaporates during use, water that's embedded directly into your chemical products, or water that simply doesn't return to its original catchment area. For instance, if you withdraw fresh water from a lake, run it through your plant, and then discharge that wastewater into the ocean, well, that water is lost to the local freshwater ecosystem. Therefore, it counts as consumed. Make sense?
Section 5. Mapping water stress.
So, just knowing the total volume doesn't tell the whole story, right? You have to connect that consumption to real geographic vulnerabilities. Entities have to map their operations against the World Resources Institute's aqueduct tool, which is basically the global standard for measuring water risk. You literally have to identify the exact percentage of your footprint located in high baseline water stress regions, meaning regions with a 40 to 80% stress level, or extremely high stress regions, which is anything over 80%.
Once you finally isolate the percentage of your water at risk due to regional scarcity, the operational reality becomes super clear. I mean, with long-term increases in water scarcity due to climate change, procurement costs are absolutely skyrocketing. If a massive chunk of your consumed water is sitting in an extremely high-stress region, that immediately signals a major risk of factory disruption and regulatory penalties down the line.
Section 6. Why resource math matters.
Look, this strict math isn't just some tedious exercise for environmental compliance officers. Not at all. Tracking your gigajoules and cubic meters exposes your true operating efficiency. Chemical entities that can drive down these numbers through alternative manufacturing processes are directly lowering their operating costs. It increases reliability, and it heavily insulates the business from community pushback or sudden, unexpected regulatory fines. It's a real game changer.
Because at the end of the day, when it comes to the chemical industry's resource math, precision isn't just a suggestion, it's the absolute standard. Understanding how to account for renewable certificates and classifying water consumption against global stress maps is exactly what separates resilient organizations from the ones just flying blind. So I'll leave you with this final thought. Is your organization just estimating its resource impact, or are you ready to build a mathematically precise, fully compliant dashboard? Thanks for joining me for this explainer.